Alright, welcome back to microeconomics. So in this second video, what we're going to be talking about is demand, and in particular, we're talking about the definition of demand and how economists talk about it and how that differs from how you may have heard about it in the past. And we'll also discuss three ways to represent what we mean by demand. So diving in, when we say demand as economists and in this microeconomic class, what we're referring to is the relationship between a good's price and the maximum quantity that buyers are willing and able to buy at that particular price. And what we're doing is we're holding all other things that influence that quantity demanded constant. Now this differs because normally, and even when economics professors are writing maybe an op-ed or something, they'll use the word demand and be referring to that quantity demanded. So there's a part of this definition that's just semantics, and that's true, but what we need to be able to differentiate is this relationship and things that shift and change the entire relationship and the outcome of that relationship with these other factors. And we'll get into later on in this chapter, this unit talking about where that quantity demand comes from and where those shifts happen and why that differentiation is important. But for now, I want you to understand is that the definition is this relationship between quantity demanded and price. That's what we mean when we say demand. The second definitional thing I want to cover is what we call the law of the demand. The law of demand is characterizing this relationship. It says that the relationship between a good's price and the quantity demanded is negative. What this means is when a price increases, people want to buy less of it. So let's say we have a good that was $25 and people were buying maybe 15 of it, and then the good becomes cheaper. It becomes $10. We're not saying why, we're just saying that happens. That what we would expect to see is that quantity demanded would rise. There would be a change in the quantity demanded. Now this is a change in the quantity demanded coming from the change in price. It's not a change in demand. It's not a change in the entire relationship. When we're thinking about demand and we want to talk about it and represent it, there's three main ways to represent demand. We can do that with a table, we can do that graphically, and we can do that mathematically. So here is a table set up, or a schedule is another way to talk about this. And what a schedule has is all of the different prices lined up with different quantity demanded, so different quantities. Demand is this entire relationship. The law of demand says that at these higher prices, there's lower quantity demanded. And that if we were to look at lower prices, we'd see a higher quantity demanded. So that's the first way to represent demand is through a table, through a schedule. The second way is to do this graphically. We can show price and quantity on two different axes and represent it with a two-dimensional graph. Generally speaking, we put price on the vertical axis and quantity on the horizontal axis. The law of demand implies that our demand curve, our relationship shown in these two dimensions, is downward sloping. It's a negative relationship. We can also show points on this graph, which correspond to points on the table. Here we have a price of 25. We could make up a number and say a quantity of 15. And at a lower price, maybe $10, we'd have maybe a quantity of 30. And again, this change in the price here and this movement along the demand curve, this is not a change in the demand. The curve is staying the same. The relationship is staying the same. What we're showing there is a change in quantity demanded. The third way we can represent demand is mathematically. So we could have a demand function, right? It takes inputs, give you an output. The inputs we're interested in would be things particularly price. So here in this mathematical setup, we have the quantity demanded is a function of the unit's price. Now there's other things that impact the quantity demanded as well. We'll get those into those in our next video. Substitutes, complements, income, taste and preferences, expectations, the market size. These first two, this is what we're talking about when we're speaking about demand. It's this relationship. These other things that impact the quantity demanded as well are our demand shifters. So to give an example numerically, we could have Austin's demand for salmon, and maybe it's 4 minus the price divided by 5 plus the other shifters. Now when we're graphing demand, we think about it as the kind of functional output is quantity, but when we're graphing it, we typically graph where our y or our vertical axis is the first left side of the equal sign, and so we'd graph it, the version that would be graphed would be price equals 20 minus 5 times the quantity. We often don't include the subscript for the individual. I'm doing that here. It's going to become relevant later, but normally it's just a Q without that subscript. Now, we've been representing one individual's demand, and demand comes from the individual level. But if we want to be talking about markets, we're going to have to think about market demand. And market demand is simply going to be the sum of all the individual's quantities demanded by each buyer in that market at each particular price. And again, we can look at this in terms of a schedule, we can look at this graphically, and we can look at this mathematically. So looking at this in terms of the table or the schedule, now we have Austin, who we saw before, but we're adding in Blake as well. And what we want to do is take the individual's demands and come up with a market demand. What we need to do for that is we just add at each given quantity. So we are going to look at the price of 10 and look that Austin demands 2, Blake demands 4, and the market demand is simply the sum of the two. So that market demand at a price of 10 would be 6. Right? And so what we're doing is we're adding quantities at a given price. Right? And so you always want to make sure when you're combining demand in this way, going from individuals to markets, or actually you can combine markets going from maybe counties to the state level, that what you're doing is at particular prices combining those quantities. We can also do this combination graphically. So here we have a graph of Austin's demand and also a graph of Blake's demand. And what we're doing is horizontally summing. So at this price of 10, we're looking at Austin's demand, we're looking at Blake's demand, and the market demand is 6, which is the sum of Austin and Blake. Now let's look at it the third way, looking at it mathematically. So here is Austin's demand and Blake's demand written as we would graph them. Now you're often given formulas this way, and you're often not given these subscripts for Austin and Blake. You're just given Q and meant to understand that those quantities mean Blake and Austin. And the temptation that I see a lot of first year students and even further along in their studies students, and I make this mistake myself, is to just, because you're moving quickly, add them together to get market demand, right? And so you kind of ignore the fact that it's price times price, and you add them together and you get this 40 minus 7Q. This is very wrong. It gets you a nice mathematical answer, which feels like, yay, I got it, and it will give you a solution to a problem. But what you're doing here is you're not adding quantities. Remember what I had emphasized before with both the table and the graph was that you wanted for a particular price to be adding quantities. Right? What you're actually doing here is you're adding prices. Right? On the left we have prices. On the right it's turning quantities into prices. They're both prices. Right? And this is incorrect. That is not how we get to market demand. Don't add prices. What we want to do is add quantities. So in order to get to market demand, we need to rewrite these functions as quantities. So I'm going to rewrite this as Austin's demand as the quantity is related to price, and Blake's demand as well, as Blake's quantity is related to price as well. The price is common across the market, right? The price that Austin is seeing is the same price that Blake is seeing. However, the quantities are individual, and that's why I'm emphasizing using these different subscripts. Because when we're getting market demand, we're actually getting a third different quantity. We're getting that the market demand is the sum of Austin's demand and Blake's demand. And once you recognize that's what we're doing, it's easier to avoid that problem. And so what we're going to do is simply add those individual demands together to get the complete market demand, which is this 12 minus 3 times price over 5. Now, if you need to graph this and turn it into its graphed form, you can then take the inverse of it. Once you add the quantities, then you can turn it into its graphed form. All right, that is our kind of unit introducing demand. Our next video in this unit on supply and demand, we're going to talk about demand shifters. Thanks for watching, and I hope you continue on in this series.